Okay, I hope I'm audible to all my students who are attending this online lecture for the Mathematics for Business Economics Part 2 course, which is currently offered in semester 3 of BA Honors Business Economics. Now, in this particular lecture, I'm going to start with the discussion of the 2024 question paper, which has come up at Delhi University for this particular course. Okay, remember it's a 3-hour paper for 90 marks. Okay, and in this particular lecture I'm going to solve question number 1. Although it says attempt any 4 questions, there are choices given in the question paper, but I will be solving all questions in my lecture videos for this particular question paper. So in this lecture, let's quickly start with the discussion of question number 1. So let's look at question 1, part A. Show that x square minus y square equal to c for all values of constant c lies on the level curve for this particular function. The concept of level curves I have covered in my lectures on functions in several variables. Students who have enrolled for my complete Mathematics for Business Economics Part 2 course, please revisit my lectures on functions in several variables for my discussion of the concept on level curves. How do I show that this lies on this particular level curve? If I solve f of xy by substituting x square minus y square equal to c, the level curve ideally is at a height, so that height should be constant. So if I come to the whiteboard to solve it, just writing the main heading for clarity. Students are also advised to open up the question paper alongside so that you can, when you are watching this video, you also can simultaneously look at the question. You can open the question paper in another tab. Okay. So this is Delhi University Exam 2024. Name of the course is Mathematics for Business Economics Part 2. Mathematics for Business Economics Part 2. Okay, which is offered in BBE honors at Delhi University. We are looking at question number 1 only in this particular lecture, part A. We are given that x square minus y square is equal to c, where c is a constant. C is a constant. And we are also given that the function is f of xy equals e to the power x square, e to the power minus y square plus x4 minus 2x square y square plus y to the power 4. Okay, I need to show that this equation for all values of the constant c is a level curve for this equation. So I need to show that x square minus y square equal to c is a level curve for f of xy. So how do I show that? I start with f of xy. Consider f of xy, which is, now students, I can write this as e to the power x square minus y square plus this I can further factorize. If you carefully look at this expression, it is nothing but x square minus y square whole square. To make you all understand, I can split the middle term. I can write minus 2x square y square as minus x square y square minus x square y square plus y to the power 4. This I can further write as e to the power x square minus y square plus, within the first term, I can take x square common. Inside the bracket, I get x square minus y square. Within the second term, I can take minus y square common. Inside the bracket, I get x square minus y square. So this I can write as e to the power x square minus y square plus this I can factorize and I can write it as x square minus y square times x square minus y square. which finally comes out as e to the power x square minus y square plus this I can write as x square minus y square cos square. That means students, finally my f of xy has come out as what? If I erase this portion off now, my f of xy has finally come out as e to the power x square minus y square plus x square minus y square cos square. Now I can just substitute x square minus y square as c because that's my level curve. So substituting x square minus y square equal to c in f of xy gives f of xy as e to the power x square minus y square is c plus x square minus y square is c cos square, which is a constant. Since c is a constant, e to the power c is also a constant. So I can say that therefore x square minus y square equal to c is a level curve for f of xy. At what height? At the height e to the power c plus c square. I can say that x square minus y square equal to c is a level curve for the function f of xy at this particular height. So I hope all students have understood how we have solved this. And then quickly let's look at question 1 part B. Find all the first and second order partial derivatives for these two functions. Now this is quite easy. Let's look at the first function, 3x square y over x square plus y square. So if I quickly come to the whiteboard, we are looking at question 1 part B. Within this part 1 is f of xy equal to 3x square y over x square plus y square. How do I find del f by del x? It's nothing but the partial derivative of the function with respect to x. When I'm partially differentiating the function with respect to x, I treat y as a constant and I differentiate. Since it's numerator over denominator function, I use the quotient rule of differentiation. So denominator function into the derivative of the numerator function with respect to x is 6xy minus the numerator function into the derivative of the denominator function with respect to x is just 2x over denominator function square. If I open up the brackets, it comes out as 6x cube y plus 6xy cube minus 6x cube y over x square plus y square whole square. This and this cancel out. So my del f over del x comes out as 6xy cube over x square plus y square cos square. Okay. Similarly, if I have to find del square f by del x square, I'll just go one more step forward. How will I solve for del square f by del x square? I'll again differentiate. So it's going to be x square plus y square cos square times the derivative of 6xy cube with respect to x is 6y cube minus 6xy cube times the derivative of the denominator with respect to x partially is 2x square plus y square times 2x whole divided by the denominator ka square, which is x square plus y square square ka square, which is x square plus y square to the power 4. And then students can again calculate. Even if you leave your answer here, it's absolutely fine. If you want to solve it further, you can also solve it further. So how can we solve it further? If I erase this particular portion off, I can write that del square f by del x square is going to come out as, open up these brackets, we can open up this bracket, or if I can just write x square plus y square cos square times 6y cube whole divided by x square plus y square to the power 4 minus 6xy cube times 2x. I can write as 12xy cube Okay. In fact, I can make it 24. 6 into 2 into 2, which makes it 24. Let me write 24 here. So 6 into 2, I see, students can see 6 into 2 into 2 makes it 24 times xy cube times x square plus y square whole divided by x square plus y square to the power 4. Now, students can see that this cancels with this, making it to the power 2 in the denominator. Because students can see that 4 minus 2 will make it 2 in the denominator. And similarly, I can cancel this with this and make it 3 in the denominator. Minus 24x cube over x square plus y square to the power. This was 1, so 4 minus 1 makes it 3. This is my answer for del square f by del x square. Now, on similar lines, students can solve for del f by del y and del square f by del y square. I will not waste time on that because you have understood the process, but I can write the answers for you. Students who are watching this lesson, please solve del f by del y and del square f by del y square on your own. Del f by del y will come out as 3x4 minus 3x square y square over x square plus y square square. And del square f over del y square, when you differentiate del f by del y again, it is going to come out as minus 18x square y over x square plus y square ka square. Solve this on your own. Students are requested to please solve this on your own. And last but not the least, I have to find out del square f by del x del y. How will I work that out? My del f by del x came out as 6xy cube over x square plus y square ka square. So how will I find out del square f by del x del y? I will differentiate this partially with respect to y. Again, I use the quotient rule, x square plus y square ka square times the derivative of the numerator with respect to y will be 18xy square minus the numerator function 6xy cube times the derivative of denominator with respect to y partially is 2 times x square plus y square times 2y whole divided by x square plus y square ka square, which makes it 4. So if you solve this, you are going to get the answer as, I can write it here. If you open up the brackets and if you solve this completely, you will get the answer as 6xy square times 3x square minus y square over x square. Let me write it clearly for all students. Ultimately, if you do the algebra, even if I want to do it, I can also do it. It is very simple. You can just divide it like this. So I can write x square plus y square ka square times 18xy square over x square plus y square to the power 4. I'm separating it minus 6 into 2 into 2 makes it 24. Xy cube times y makes it xy4 times x square plus y square over x square plus y square to the power 4. So students can see if I write the answer, I am erasing this particular portion off now. And if I write the answer for del square f by del x del y, it comes out as 18. It comes out as 18xy square. It comes out as 18xy square over x square plus y square ka square, because 4 minus 2 will make it 2 here, minus 24xy4 over 4 minus 1 will make it 3. So I can write x square plus y square cube. This is my answer for del square f by del x del y. And by Young's theorem, I have covered Young's theorem in my lectures on partial derivatives. by Young's theorem, del square f by del x del y will be equal to del square f by del y del x by Young's theorem. They will be equal to each other. Okay, so I hope all students have understood this. I stop in this particular lecture. In the next lecture, I'm going to solve part 2. Question 1, part B, part 2 is what I'm going to solve in the next lecture. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.